So this is lab 2, where we revisit the charge tape experiment, and my name is Paige Mayfield. So in this lab, we are going to be creating a computational model where the charges are spread evenly across the length of the tape, whereas in lab 1, we concentrated the charge to a single point on the tape. So for this, we're going to do some fundamental principles of Newton's second and third law, Coulomb's law, and electrical force on an object, and electrical field charge. So to do this, we're going to use the starter code given to us and put it in GlowScript. And then we're going to add our own information to this model and run the code and create a visual representation of the electrical interactions on the tape. So for this, the systems are the same as the first lab, with the floating U tape being the system and surroundings being earth, lower charge tape, and air. So some possible sources of error could be mistyping in the code or incorrect pasting of the starter code. So the magnitude was calculated by the model to be here. So it was 4.1 and then 1.962 for gravitational force. And we made some assumptions for this. So we are going to ignore air resistance on a moving object and assume that the U-shaped tape that we made had the same charge, evenly distributed along the length of tape. So what if we had modeled our tape as a single point charge like in our previous lab? Our estimated value would have been 1.75. And then you compare that to what we calculated with the line charge model, and you see that it's different. So why do these estimates differ? So the line charge model is giving us a more accurate result because it's distributing the electrical forces evenly, it's distributing the charge along the tape instead of assuming a point like the point charge. The point charge model is underestimating the value, and the line model is going to be closer to our real value. So here's the code. You can see here we put in our distance, our length, and we changed the scaling. And then this was the model we created, and these are the magnitudes calculated. So in conclusion, the line charge model is a more accurate representation of the electrical forces interacting between the two charge tapes. The line charge model distributes charge along the length of the tape. So the line charge model is going to be a more realistic computational model of the charge. Thank you.